All right, let's just give the 1 more minute. We usually start 2 minutes after. That's our San Jose State timing for how long it takes. All right, it looks like they've done the fancy pinning of the screens. Yeah, good afternoon, everybody. Thanks for coming. For those of you who participate in the Go program, just a reminder that this event counts towards the Go points. Hopefully at some point, Sanella or I can put the Go program link in the chat. I'd like to welcome everybody to our Silicon Valley Leaders Symposium series. And today I'm delighted to welcome back Philip Barros, who is Chief Technology Officer of Ichor Systems, which is a worldwide company located in Fremont that designs, engineers, and manufactures critical fluid delivery systems and components for the semiconductor capital equipment. Mr. Barros is one of us. He earned his degree here at San Jose State in mechanical engineering. From the year 2000 to 2004, he held engineering and management positions at Applied Materials. He joined Celerity in 2004, which was later acquired by Ichor in 2009. And during that time, he held multiple leadership roles, including Vice President of Engineering and Director of Systems Engineering. Before becoming the CTO in September 2015, Mr. Barros led Ichor's engineering organization as Senior Vice President since 2009. So once again, please help welcome Philip Barros, CTO of Ichor Systems. Handing it over to you.
Yeah. Thank you very much. I really appreciate it. I think you gave a better introduction to myself than I ever could. But once again, I'm Phil Barros. I'm alumni of San Jose State. I graduated in 2002, and as Cheryl said, I started Applied Materials. Started my career as an intern at Applied Materials. So during my time at San Jose State, interned at Applied Materials, who's now one of our biggest customers. So it's ironically, talk about that in a little bit here, and how I got there. And then I've been here since it's going on 18 years. So it's been a long ride with Ichor Systems and its predecessors. When I joined the company, we were a smaller company around the order of 25 million in revenues. This year will be our first year above $1 billion. So it's been a large, a fun journey for me and the staff here at Ichor. So thank you for having me. And with that, I'm going to start a presentation. I hope you guys can all see. Okay. What I'll do today is I'll give you a quick overview of Ichor. I'll give you kind of overview of the company, give you an overview of the industry, as well as our products. I'll follow that up with some words of advice. Some words of advice I wish I had when I was a student at San Jose State. So hopefully that's helpful to everybody. Then after that, I'll talk about how you get involved with Ichor Systems in terms of careers, internships, and what we're doing at Ichor, and hoping that you guys can help us out there. So this gives you an overview of Ichor. This is a high-level view of what we do as a company. As Cheryl said, we are the largest supplier, largest provider of gas and chemical delivery systems to the semiconductor manufacturing industry. So people ask me at parties all the time, what does that mean? Really what that means, in order to make a microchip, what those companies are doing is they're buying equipment from Applied Materials, Lam Research, companies of those sort, in order to make those microchips. What we do is we provide a certain subsystem that goes into that equipment, and we're a critical subsystem. I'll talk about how we fit in a little bit more in a second, but we're a critical subsystem to that piece of equipment. In terms of facilities, we're a worldwide company. We have 14 sites worldwide, 5 different countries, really strategically located both to our customers' engineering teams, as well as their manufacturing sites. In terms of employees, currently we have about 2,200 employees and growing fast. And down below, you'll see why we're growing fast in terms of headcount. In 2019, we were around 620 million. This year, as I said before, we'll be eclipsing the $1 billion mark, which means we've almost doubled in the last 2 years. So we're seeing a lot of growth, a lot of exciting stuff going on in our industry, and I'll explain that in a little bit here. Over on the right-hand side gives you an overview of the products we build. I'll get into those a little bit more in detail. I don't want to confuse you too much with these pictures, if you will. So where do we fit in the supply chain of the semiconductor manufacturing equipment? So if you look at the bottom, as I said before, the device manufacturers, so the Samsungs of the world, the Intels, the companies you've probably heard of, they'll buy equipment for companies like Applied Materials, ASML, Lam Research, TEL. Those are really the equipment suppliers. And what they're doing is they're creating equipment that's used to manufacture microchips. In order to make that equipment, what they've decided to do is go to subject matter experts in order to help them create the best equipment they can in their space. And what they've done is outsourced different sections of the tool to key suppliers. So where we fit in is we're on the fluid delivery side. So we're the critical subsystem provider for the fluid delivery systems. That's both gas and chemical when I say fluid, just to be clear. We're the fluid system provider to those OEMs and to those manufacturers. So that's kind of where we fit into the overall supply chain. So there's a lot of information on this chart, but this shows you some of the exciting trends that we're seeing in our market. Above and beyond the usage of chips, so there's a big expansion of usage of chips. So if you were to look at a car 10 years ago, there was maybe one microprocessor on there. Today, a car has more processing power than your typical iPhone or your typical computer. So we're seeing chips go into places where they weren't before. But above and beyond that, there's two real exciting trends that are happening in the industry, which is driving really the expansion and need of equipment. I'll talk about two of those here. One is NAND, so that's memory. In order to increase the memory density, what that means is, if you look at your iPhone, so inside my phone, I used to be able to hold, maybe 250 megabytes of data when I first bought it. Now I can hold a terabyte of data in my iPhone. And the reason for that is the memory is becoming more and more dense. They've gone to a process which is called, basically they've stacked the layers. So in the same footprint, what they'll do is they'll increase the number of layers. That's called 3D NAND. And what that is doing is allowing you to get more memory in the same footprint. So basically more memory density. And how they do that is they do more and more layers stacked on top of each other, which requires more and more process equipment to either etch or deposit those layers in order to build those structures. So with that said, a typical NAND structure maybe 3 years ago was about 64 layers. We're moving to next year where the primary NAND market is going to be at about 256 layers. So you can see there's a fourfold increase in overall NAND and capital intensity there. So what that's doing is creating more and more demand for capital equipment. We're seeing the same thing happen on the foundry and logic side. So once again, that would be your logic devices, your Intel, AMD, things of that sort. What they're doing is going to what's called gate all around. They're moving from, there's a transition from what's traditionally called FinFET over to gate all around. And without going through all the technical gory details of what that means, in essence, what it means is they're able to put more transistor density in a smaller footprint. What that allows you to do is have more clock speed or faster processors in a smaller footprint. Okay. Once again, the thing to keep in mind there for our industry is because of those more complex geometries, those more complex designs of the chip itself, what that's creating is the need for more and more and more process equipment. So in summary, the one thing I want you to take away from this slide is chips are becoming more and more complex. There's a growing demand for chips, and that's what's really driving the expansion in ICorp's market. So what does all this mean? Okay. wafer fab equipment, so WFE, is basically the market for wafer fab equipment. We're seeing a 13% growth rate, which is very healthy for any industry, to see a 13% growth rate over the last 6 years. A subset of that market, which I would call dry etch and CVD, is where we heavily play. About 75% of our business in that market, in the etch and CVD market, chemical vapor deposition market, is seeing a faster growth because it's more intense to making the chips that we talked about there. So we're seeing about a 15% growth there. Above and beyond that, Ichor is seeing about a 26% growth over those each year on an annual basis since 2015 for two reasons. One, driven by the wafer fab equipment spend, and then two, we're quickly gaining market share, and I'll talk about how we're doing that in quite a second here. Okay, we talked about our global presence. This gives you an idea of where we're located. Once again, 14 general locations around the world, 15 different countries that we are represented in. Anything from a sales office, headquarters, to manufacturing in Fremont, all the way to pure manufacturing in Malaysia, in South Korea, and Singapore. Okay. This is my favorite slide because this starts to get into what we're what we do in terms of products. So, like I said before, about 75% of our revenue comes from what we call gas delivery systems. Okay, and that's what you'll see over there on the left. That's kind of the inside of what a gas delivery system. It's usually inside of an enclosure. You see in the picture in the middle, it's highlighted in green. A gas delivery system essentially delivers the gas to what we call the process chamber. So I keep using this word process tool, process chamber. They're synonymous with each other. But long story short, what a process chamber is doing is it's really a reaction chamber. Okay. And at the end of the day, at the simplest form, what our customers care about is that they're trying to facilitate a chemical reaction at a microscopic level. Okay. In order to do that chemical reaction, they need to control four main process variables over on the far right-hand side. They need to control power, they need to control pressure and temperature in order to make sure you have the right environment. And then obviously you need to control the chemistry. Okay. And where we fit into that whole environment is we control the chemistry. So we're delivering the gas at a very precise amount in order to get them the repeatable results that they want in terms of that chemical reaction. So at the end of the day, all these customers and suppliers, what they're trying to do is facilitate that chemical reaction. We're at the heart of that by giving or by delivering that chemistry to that chamber. Okay. This gives you another view of what a typical gas delivery system would look like. Once again, one of my favorite things to talk about here is because this is, as an engineer, exciting to me. Essentially, historically, what Ichor has done is we've been an extension of our customers' design teams. So we help them design the gas delivery system because of our expertise in gas delivery systems. But we've purchased all those components to manufacture from third-party sources. One of the main shifts we're making as a company is one of the reasons for some of the market share gains that we talked about before. One of the main shifts we're doing is we're becoming more and more vertical, or basically making those parts ourselves. Okay, we started with some of the easy stuff like precision machining. I say it's easy, but it's really hard in our environment to make sure that some of the corrosive gases don't eat away at the machine parts. Weldments, which are basically becoming as high-tech plumbing. Then we moved next on to what I show here. I hope you guys can see it. But essentially a pneumatic valve, which is an on-off shut-off valve, really is a safety feature. Then we moved on to seals. Obviously, when these components are connected, you want to make sure you do not leak. That's a critical feature. And where we're at today and spending a lot of our R&D time and energy is on filters, heaters, and flow controllers. And when I say flow controller, think of the flow controller as really the brain and the heart of the system. So what that's doing is really controlling the amount of gas that goes through that process chamber that we talked about. So that's really the heart of the system. We've developed a new technology to do that. I'm very excited about where that's at. Still in the very early stages, but with that said, I think it's a kind of a state-of-the-art technology that's going to allow us to help with kind of the next generation processes. Okay. And if you look at it, the next segment of our business, it's about 20% of our business is chemical delivery systems. Okay, wet chemical delivery systems. Biggest difference between the gas systems and the wet chemical systems is the wet chemical systems are typically used or made out of plastic versus stainless steel. Reason for plastic is the corrosive nature of the wet chemistry. So PFA, PTFE, they'll fare better with those chemistries than anything metal. With that said, it's serving the same purpose. It's really controlling that chemistry used in that chemical reaction for that process step. Once again, another exciting thing here is this is a product where I would say we're under-penetrated in, and we have a strong opportunity to grow. And I'll talk about that in just a second. The balance of our business is actually kind of an offshoot of what I talked about before. So there's a lot of stringent requirements for how gases are treated and how gases are moved from one spot to another within a process tool. And when you can do that repeatedly, you will get opportunities outside of the gas delivery system. So maybe on the process chamber, maybe there's parts that are on the waste lines, things of that sort. So we do what's called weldments and subassemblies and precision machining that go other places on the tool as part of our service. Okay, so this gives you an idea of where we have share today and where we have opportunities to grow. So I talked about before how we're gaining share, and that's one of the main reasons why we're outperforming the market. But in general, anything you see here in orange is where we have a strong position. Anything shown in gray is either an opportunity that we have identified or have actively engaged with the customer to grow within. So we have a strong opportunity. I talked about the chemical delivery market. I'll use that as the example here. The chemical delivery market, a lot of the suppliers, or so the tool manufacturers for the chemical delivery market are in Japan. We typically have not had a strong presence in Japan. We're now working with a partner in Japan in order to strengthen our position in Japan and have some great opportunities to grow that share there. So we have a unique technology for how we blend and how we distribute the chemistries. The Japanese market seems to be taking a good, or seems to like the technology that we're presenting. So with that said, it's a large opportunity for growth. So once again, I see over the next 5-10 years, a lot of opportunity for Ichor to grow, both organically and inorganically. Okay, now I'm going to switch topics here for a second and talk about what I would see as words of advice. The way I had this first bullet written at first was don't let fear get in your way, or something of that sort. But the way I really want to say is don't let it stop you from reaching outside your comfort zone. Okay. When I took the internship at Applied Materials in 2000, I had no idea what a microchip was. I had no idea what a process tool was. And there's no way I knew what a gas and chemical delivery system was. So with that said, I took a little bit of risk. It was way outside my comfort zone. I was dealing with mixing and blending of chemistries that I've never heard of, right? Way outside of my comfort zone. But I didn't let that stop me. I took the job and I learned a tremendous amount there. I really credit that internship as giving me that subject matter expertise that allowed me to grow in my career. So I think that was probably one of the best career decisions I ever made, was taking that job. And how I got through that is I found a mentor. So that leads you to my next bullet here. The mentor that I took on, his name is John Lane. He helped me understand how each of those components worked and how I needed to test those and how I needed to qualify those and what was important. Those are all things you won't find in a textbook, right? So it's always good to have a good mentor in your space in order to help you feel more comfortable with with what's going on around you. The third one here, and it seems pretty simple, but I'm seeing it as more and more of a challenge these days, is be accountable. So do what you say you're going to do. In this world of Zoom, in this world of being remote, and I don't see this fully going away anytime soon, right? I think at some level, people are going to work from home, whether it be temporarily or, a kind of a hybrid model, whether it's you come in the office a couple days a week, you work on Zoom for a couple days a week, whatever. It's really important that you're accountable, okay? And you're not going to have a manager looking over your shoulder all day long. You're not going to be able to have somebody say, hey, I need this done tomorrow. You need to be able to do what you say you're going to do. And I promise you, if you do that, it will be recognized. The next one here is make your manager or customer a success. And I'll just give you an example here. Most of my customers are engineers. Okay. And the reason I believe I got to where I am today is I made my customers successful. What I did early in my career is I helped my customers solve problems that they could not solve on their own because I was the subject matter expert, right? And what that allowed them to do is they were successful in their job, and the loyalty you'll get from that is unbelievable. So that works the same thing for your manager. Obviously, the person who's writing your review, the person that's giving you a promotion, you make them successful, they'll make you successful. And then the last thing on here, and I'm sure you've heard this a million times, but be a constant student, right? I learn something every day. Just because school's over doesn't mean learning's over, right? I learn something new every single day. And a lot of it comes from the young employees we hire, right? I think people coming out of school today know more than I ever will. But with that said, there's always an opportunity to learn, and just please don't ever forget that. Okay. With that said, at ICorp, we do offer paid internships. We're very flexible in terms of those internships. And they could be in the form of co-ops and things of that sort if you want to do it during your working time. But like I said before, one of the most important things to me, or what I think was one of the most important steps in my career, was taking on an internship. That allowed me to learn practical hands-on experience of what goes on in the workplace. And I credit a large part of my success to that. With that said, I got that through San Jose State, and I thank San Jose State for helping me get that internship. So, specific areas for where we look to hire today, it's mechanical engineering, electrical engineering, software, so pretty large breadth. Supply chain. Engineers don't normally think they can go into supply chain, but believe it or not, supply chain is one of our biggest problems in the world today. And I believe that engineers make some of the best supply chain people there are. And the reason being is because they understand how the products that they're looking for work, and they might be able to find alternatives in order to meet the same need. And so I think it's important for engineers to think about also going into the supply chain market as well. Systems engineering, that's always key because obviously we build and develop systems. IT, as well as business analytics. Once again, not always something that engineering students think about, but in terms of business analytics, that's an area where we can definitely use some help. Any questions or anything at all, please reach out to Michelle. She's in charge of all of our hiring and our staffing. So she'll have all the postings. She'll have all the information you would need in order to get in contact with either myself or with anybody within our organization. So with that, I think that's opened it up to questions and answers.
All right, that was great, Phil. I'm sure there are questions from students, so I'll invite, we're a small group, so maybe what we could do is stop the share screen if that would be okay.
Sure.
And we can have students either put questions in the chat, or if you want to raise your hand, we can have you just unmute and say your question. Maybe while students are thinking or typing their questions, I'll put one out there. You said that we shouldn't let fear stop you and from getting outside of our comfort zone. And you gave some early career examples. I'm wondering if you would have some more recent examples you might want to share about that.
Oh yeah, so I'm in, believe it or not, I'm in charge of mergers and acquisitions too for the company.
You took that class in college, right?
No, I did not. And once again, that was something I saw a gap in the company. We had a lot of opportunities out there and nobody was filling the need that we needed as a company. So I kind of took the leap, went out there and once again, not my comfort zone, but it all goes back to finding somebody you can trust that can help you get through that fear, if you will. I think that's important. So found a good banker. That's always helpful in that regard. Helped me fill up the gaps that I didn't have, and I think that's also been helpful as well. So.
Wow, mergers and acquisitions. Okay. um, how about another question that may be on the minds? Oh, we've got one. All right, great. Thank you, Charlie. In what area did you do your ME capstone course in? And then how did you decide to go into the semiconductor industry? Or maybe what was your mindset before taking that applied materials internship? And did you have something else in mind or were you just really open?
I think I talked to you about this before. I
Yeah.
went into mechanical engineering to design roller coasters. And obviously I'm not designing roller coasters today. I would say that the semiconductor industry kind of found me, if you will, and it was an opportunity I saw out there. As I said before, I had no idea what the semiconductor industry was. I had no deep knowledge of it, and I came from the East Bay where we didn't care about the Silicon Valley as much, right? So we didn't know who Applied Materials were. We didn't know Intel at the time. So all that said, I really, when I started the job at Applied Materials and when I took the position there, which by the way, when I interviewed, I thought I bombed. Didn't think I would get the job. Anyways, long story short is when I took the job, I really enjoyed it. I really took a liking to it, and that kind of kept me there. In terms of capstone, I was machine design was my kind of emphasis.
Yeah, that sounds like it's really, really useful.
Yeah.
Great. How about in terms of things that you look for when you're trying to hire? What are characteristics that make folks stand out? I mean, you said you thought you'd bombed in the applied materials interview, but you must have done fine there. But when you're on the flip side of it, what do you look for?
Yeah, a couple things. First of all, is just general attitude, right? So I want somebody that you can tell is eager and willing to get their hands dirty, right? And you can usually find that out in the first 5 minutes of an interview. You can find out whether or not somebody is willing to take on more than kind of what the job description is, if you will, and be eager to learn. I think that's very important, especially for somebody coming out of school. I would say that next to that is just general experience, whether it be personal experience. So, for instance, what got me the job at Applied, which I had no idea, was my hobby was, so I race bikes, and I raced bikes back then. So I had a very high mechanical aptitude, right? So I was taking apart bikes and rebuilding bikes and things of that sort. And part of that job at Applied when I started was you needed a strong mechanical aptitude to be able to put things on test fixtures and wrench and all that stuff for testing. And so those are the type of things, whether it's work experience, whether it's in the classroom experience, or whether it's just your personal experience. I think it's important to explain to them, if it's relevant to what you're applying for, explain to them how your life experience has been able to help you be ready for that position.
Great. Yeah. So just a clarifying question, when you say bike, you mean a non-motorized bicycle, or do you mean motorcycle?
Non-motorized bicycle, but still just as dangerous.
Oh yeah, no, absolutely, just as dangerous. Anyway, this is really important advice. I hear from students a lot that sometimes they don't want to put non things that they think are not technical enough on their resume. But if you're in a club that's on the bike club, or you're doing other things that way, I mean, I think these are all really important things that companies are going to look for.
Very much so. And you never know too. You might have a common interest with the person you're interviewing with based on that as well. So that helps as well.
Yeah, we had a commencement speaker that spent most of his applied interview talking about his experience in the construction industry before getting his mechanical engineering degree. So yeah, and that's how he started. It he might not have started right. It might have been with another company before he ended up at applied, but same. Yeah, other questions from students? Oh, yeah. Oh, and advice for new grad school students. So I'm sure your company does hire a few people with advanced degrees. So do you have advice you might share for people that are just starting their master's program? Thanks, Tulin.
Yeah, I would just say once again, while you're doing that master's, if you could look for an internship, I think it's highly valuable, right? You're going to learn a lot from a book, but you're going to learn even more in a week with that hands-on experience. I think it's very important to see if you can get that internship to widen your kind of area of expertise, if you will.
Yeah, and I would put it out there for students to look to get involved in club activities. And so we have hands-on club activities. So we'll take, graduate students in electrical engineering to be a part of our Formula Car team. You just have to go out and talk to them during, just go to a club meeting, go to recruiting events, or be a part of, keep going back to IEEE has hands-on activities and things that they run out of their club. And so that gives you project experience, which helps to get you into the door for the internship.
Yep.
So just things to keep in mind, and also learning how to package your projects for class so that you can highlight what you're learning there that's relevant. More questions from students. Are there other things you're learning, Phil, besides mergers and acquisitions? Because you said that our students, when they're done, they should still remain a constant student.
Well, I'm learning like everything I talked about with NAND and logic. That's not my expertise, but I'm happy to learn it, right? Because what's important for my position is I need to make sure I have a technology roadmap in place that meets the requirements of the industry, right? So I constantly need to know what's important to the process, right? So whether it's accuracy or response time or things of that for the gas delivery. I constantly need to understand what's going to help them be successful so that we develop products that are going to help bring their process to the next level. So it's a constant learning experience.
All right, other questions? It's a neighbor's child that's crying in my neighborhood. If you hear home day for me. So maybe I could ask, since your business is going crazy, how do you maintain work-life balance? Do you have any advice there you could share with our students? Because I know our students often struggle with this too, especially as we get further into the semester.
Yeah, it's a great point, and I highly recommend. I say it to all of my employees that you need to make time for yourself, no matter what. Right? Do not take on too many classes that you think you can't make time for yourself, because your mental health is more important than anything else. Because if you can't maintain the mental health and maintain your overall health, it's just going to be a train wreck, to be honest with you, long term, right? So I talked about racing bikes. I train a lot, and the reason I train is really it's my stress outlet, right? I have a high stress life. I have a young son at home, and it's all of that put together. You need to make sure you set aside some time for yourself to get that stress relief, because it piles up if you don't, to be honest with you. And my outlet is riding my bike. It allows me to, get things off my chest. Allows me to, and also some of my best ideas come off my bike. So I think it's really important to make sure you set time aside for yourself, no matter what's going on in your life.
Yeah, I would echo that as well. Other questions from students? Again, if you want to unmute, just raise your hand. If you want to put it in the chat, that's fine. Anything you would have done differently as a student, Phil?
I would say that it's a hard question.
Yeah, this sounds like you did have some really good things happen along the way and good choices that you made, which is great.
Yeah, I think early in my college career, I was probably less focused than I should have been. But it happens. But I think over the time during college, I got more focused. But that's probably the one thing I would change is focus.
Mm-hmm. Yeah, I guess the challenge with the engineering curriculum is it kind of scaffolds on itself. So if you missed a few key concepts in a physics class or a lower division mechanical engineering class, they come back potentially to haunt you. So Justin has a question about where will the recording be located. I think we post these on the SVLS page by each speaker. There'll be a link to the recording. So I think there were a few students who came in late, and you can catch the front end of that there. You're kind of a quiet bunch. Oh, Xenol is confirming it will be on the SVLS page. Maybe I'll ask a question just related to the cyclical nature of the semiconductor industry, because there's a really big capital expansion going on now, and you'll be a part of that. But where do you see? I don't know how. I mean, those fabs are so expensive. If this is going to go on infinitely, or if it's going to plateau, and then where would the growth opportunities for ICorp be at that point?
Yeah, I would say there's no secret that semiconductor has always been a cyclical industry. But what we're seeing in terms of trends is because the number of device manufacturers is shrinking, the shapes of those curves or the kind of the amplitude, if you will, of those cycles are starting to get smaller and smaller. So we had for instance, 2019, we had a downturn. Downturns in our industry are typically 18 months to 24 months historically. That one lasted about 6 months. So that gives you an idea of the overall trend.
Wow. Okay.
So I would say that the overall cyclicality of the business is getting smaller. But with that said, if you go back to my bubble chart that I showed earlier, we have a lot of opportunity for organic growth. So a lot of opportunity for us to take the products that we're already developing and insert them into new markets. And we'll talk about, and I actually like downturns personally for one reason and one reason only, is that's when our customers have the most opportunity to qualify new products, right?
Ah, okay, yeah. So they're not just trying to make everything perfect, at specification, and they can try new things.
They can try new things. They have, today a lot of our customers are challenged with getting the product out the door, right, and making sure that there's enough in the supply chain and helping all that out, where during downturns they can spend more focus on new development, new products. So so I would actually say on the engineering side, I would say that the downturns are actually helpful from a supplier standpoint.
Yeah, that's an interesting standpoint. I hadn't thought about that before, but it makes sense. Yeah, I went through the experience of trying to help my daughter buy a gaming computer. So I know how hard the factories are working. So they're definitely not going to shut down a line and let you try something out and see if try to get that qualified for sure.
Exactly. Yeah, if they're doing customer demos or things of that sort, it's difficult to get tool time to qualify a new system.
Oh, this is a great question. So from Maximilio, you're in charge of mergers and acquisitions, but do you see Ichor ever getting acquired? It's definitely, this industry tends to do a lot of consolidation.
Yeah.
Good question.
There's always opportunity for higher level consolidation. I would say right now we're trying to be consolidator instead of a consolidatee. But if the right opportunity came, I think we would entertain it. But I obviously can't speak to whether or not that has happened or is going to happen. But long story short is we're well capitalized. We're a public company, so it's been helpful to have that public currency, if you will, to allow us to do acquisitions and allow us to continue to grow and capitalize the business. There's no need for us to be acquired at this point. There was a point in time when I would say the likelihood would be higher before we were public. We were actually one of the first equipment companies to go public. I think over a 15-year period. So in the semiconductor market, for 15 years, no equipment company had gone public. So we were the first one in 2016 to go public since I think it was 2001.
So I'm curious about just that in and of itself. What was the differentiator for Ichor, or what was happening in your sphere at that point?
So we were experiencing pretty rapid growth. So it kind of gave us an open window to go public. And it literally, we had about a 3-month opening. And if we didn't jump through that 3-month opening, it probably wouldn't have happened. So it was perfect timing. The market was doing well. The overall economy was doing well. And Ichor as a company was doing well. So it kind of, everything aligned. Historically, there was not a lot of appetite, or before then, people were concerned about the cyclicality, just like you were talking about. We had just gone through a short downturn, so I think there was some, or a little bit more comfort level with that. So I think that was allowing things to kind of settle down. We have since we went public, we've seen a couple of other equipment companies go public. So it's kind of like we opened the floodgates a little bit, if you will.
Yeah. No, that is really interesting. Yeah, I guess, yeah. So I think you and I, we both grew up in the same place, and just kind of watching the industry go up and down. It's been good to see all the diversification of our region so that we're not all dependent on one thing. So
Exactly.
We're not a concentrated cluster economy like Detroit, and that's good. All right, other questions from students? We've still got some time. These have been great questions. All right, I think we just have kind of a quiet bunch. So
Do that or put everybody to sleep. Either way.
yeah. No, not sure about that. We're definitely deep in the midterm zone, so we're in that part of the semester. All right. Yeah, thanks, Charlie. So what is one of the favorite things you do on your daily workflow?
Okay, so I talked about mentoring before. To me, that's actually my favorite part of my job now, is being a mentor to other people. I have a lot of younger employees. Like I said before, when we went through the beginning of the presentation, if I'm at a party and I explain what I do for a living, everybody looks at me and goes, "What are you talking about?" Right? So we get a lot of young employees in that have no idea what our industry is and what we do and how we do it. And so helping other people through the ropes and helping people grow is really where I find the joy in my job. I would say that's my favorite part.
Nice. So those are the meetings you look forward to.
Those are the things I look forward to. There's always things you don't look forward to, but those are the things you look forward to.
Great. Yeah. So maybe I'll ask a question then. I'm going to get back to what you were thinking when you came to study engineering. Do you ever want to go make roller coasters anymore?
To be honest with you, no.
Okay.
To me, it was just a thought in my head. Mechanical engineers, they can design roller coasters. Okay.
All right. But it got you into mechanical engineering, that thought. So that's good.
Exactly.
Yeah. So here's another question then. So where do you see yourself in another 5 to 10 years? So obviously it's not going to be making roller coasters. So, what might be next for you?
Yeah. Well, like I said, I've been with the company for 18 years. It's kind of almost like a baby to me, if you will. So I would definitely hope I'm still here. I think my next move would be more of a president's type role and keep growing within the company. So that's where I would see myself in maybe 5, 10 years.
Nice. And then here we've got a question about transitioning fields. So it's really good to know somebody's coming into industrial and systems engineering, because that's a place where I think, supply chain and manufacturing efficiencies and all of that. But they just changed into ISC, it looks like at the start of the semester. So as a beginner in this field, is it possible to grab that opportunity, or is it necessary to start an internship such early? Not quite sure the wording on the question.
Yeah, I would say that it's never too early to start an internship. I think the earlier the better. Even if you're new to the role, it's the earlier the better, because I think you're going to learn a lot on the job. And as long as you're willing to be a sponge and take up the learnings from the job, I think you'll do just fine.
So your company's open to looking at interns that are not just that summer before they're going to graduate kind of level. They would be a little earlier in career.
Oh, yeah, especially for instance, industrial engineering would be great to have somebody in our weldment facility that's in Fremont. And the earlier the better.
Yeah, that's good.
The manufacturing lines and things of that sort.
Great. Yeah, and it's also nice to hear. I mean, we appreciate students coming to engineering, and if you're transferring, you're going to bring that part of your education with you that you started and that you have interests in, and that'll carry through one way or the other. So, people that might have taken some art classes, that you'll never know when you're going to need that. Could come in handy.
Exactly. They can help us with logos and things like that. So that's good too.
Yeah. No, just yeah. No, it's just really good. There's a need for all kind of diversity everywhere.
Yep.
All right. Any last questions for Phil? All right, kind of doing that 10-second pause, still not hearing anything. I think maybe with that, let's thank Phil again. It was just really great to have you back. And that was a very energetic talk. I mean, I'm a chemical engineer, so of course, I think we've talked about this before. I love that side. But it's just really, really great to hear all the great things your company's up to, and your advice is wonderful. Thank you so much.
Fantastic. Thanks for having me. Really appreciate it.
Yeah. And if you can stay on for a little bit, we've got Sela, who was able to join us. And so we can say, see you at the next one to all of our wonderful students. And then if you can hang on for a few minutes, it'd be great.
Sure thing.
All right. Thanks everybody for coming. Don't forget the Go points.